Okay, so welcome again. ReCOver++, a wrap-up of the project. So the title of the project was the same as the title of this webinar, Improving Resilience of Buildings to Overheating. And you see here at the bottom all the partners who were involved in this project, what was a collaboration between university and industry. So I will start with some challenges. I think it's not news anymore that heat waves are worldwide becoming more frequent and longer, and that's what you see, for example, on the right side. You see there the top 30 severe heat waves in Europe, and you see that the duration is becoming longer, but also the temperature and so and also the frequency. But our contemporary buildings, but also the older buildings, are really vulnerable to face these extreme events of shocks. So what we want to know is how are these buildings, and including the systems, of course, react to these shocks. And then you can think, yeah, okay, how severe is the impact of the shock, but also how long can buildings withstand these shocks? How long is the absorptivity? And also the recovery we are interested in. How quickly can buildings get back to the acceptable indoor conditions? And that's what you see here at the bottom in the figure about the thermal comfort. You have a shock, and then the thermal comfort decreases and hopefully recovers afterwards. And that's what we call a resilient building. If I go further with the challenges, then we want to understand how do buildings react, and also the HVAC systems, of course, how do they react to these shocks? Because yes, it is not yet familiar that we include this in daily design practice, but that's why we give you later on two witnesses about this daily design practice. There is not yet a framework in building standards. They're really working hard on this, so that's already good news. And also, there is not so much knowledge about how building design, which building design parameters influences this resilience of buildings. We know, of course, a lot about overheating, so we think it will be the same, but is it? We are not sure about this. And there is a need for a resilience indicator that can explain how buildings react to shocks, but also that you can communicate with stakeholders. Like, for example, you see on the bottom a scale like this from green to red, for example. And also, I think it's interesting for the industry, and that's what I want to show to you is we had already this presentation, this session at the AIVC conference last year in 2024. And we had a small session with 35 participants, and you see some from industry. And we asked them two questions. We asked them more questions, but these two are interesting to show you today. How important do you believe it is to consider resilience to overheating when you are designing your buildings and systems, or when you are evaluating the performance of a system? That was the first question. And the next one was, have you previously considered resilience to overheating in your professional practice or research? And I will show you the answers. The answer on the first question was, of course, they found it really important to consider resilience because people were interested in it. That was not so strange to us. But the next one is really interested. Have you already considered resilience? And then you see that almost half of them said yes, often. 1/3 said sometimes, and then you had 1/3 no, but I'm thinking of. And it's for these two last groups of people, we said that's the reason why we did this research. Because we want to improve, of course, resilience of building to overheating, but also making resilience a more tangible and actionable concept for all kinds of professionals, architects, engineering offices, and manufacturers. Because we see that there are still people that want to use it, but did not till now. If you look a bit more in detail, then what were the objectives and what we did? We quantified relevant type of shocks along severity and duration, and we focused on heat waves. I will show you just after this. We identified the most influential parameters of building design, built environment, and HVAC system. We defined a new resilience indicator that will be presented by Dua Al-Assad after this presentation, considering the impact of the relevant shocks and also reflecting aspects of resilience. And there we focused on the impact. And it is together with some kind of scale that we Dua also will present to you. And we identified resilient demonstrators where we had a look against resilience of design and cost. And that will be shown by Joost de Klerk and Deborah Resta. Just some slides to visualize these objectives and what were the results. Here you see how we defined the shocks. We defined it like a degree of shock, and degree of shock is the relative deviation of temperature multiplied by the relative duration of the shock. So two parameters, the temperature deviation and the duration. And for example, here you see that we focused on heat waves. Here you see, and we focused, of course, into the climate of Belgium, in this case of Ghent. But we have this also for other climates. And you see here the degree of shocks for 6 extreme heat waves, the historical ones, but also some of the future, midterm future and long-term future. And then you see indeed here the relative duration of these shocks and also the relative severity of the shocks that can happen. About the most influential parameters, you see here the graph where we tested a lot of parameters that we took from our experience and expertise, but also from literature from overheating. And we did it with a regression analysis. And you can see, and I highlighted them in red, what were the most important parameters. In this case, were the window-to-wall ratio, the solar shading when it was on or off, the natural night ventilation as an example of passive cooling, and also the cooling capacity of an active cooling. These were really the most influential parameters, but of course the other ones are not. It's not that they are not important, but they're a bit less important. And then here you see already an overview of the resilience indicator and scale. So you see that it's divided by the type of building, a residential or an office building, by the thermal mass category, and by strategies of shading, natural night ventilation, and cooling. But this will be introduced to you more by Dua Al-Assad. And then here you see already a photo or picture of the demonstrators that we tested by the partners, and their partners are mentioned. Arcadis Belgium, Deborah will present later to you an office building. Archipelago also their own office building, and we also tested a residential building, the Renson concept hall, but that will be not presented today. Okay, that brings me to the end of my presentation about what is the project about. And now I want to ask Dua Al-Assad to present the indicator. Thanks, Dua.